So in mathematics, a function is just another term for reliable predictability. So what I mean by that is, when we're dealing with functions, each individual input that you put in, which is your x, each individual input, or your x, can only have one specific output, which is your y. So what does that mean? The best illustration I could think of is using a vending machine. If I go to a vending machine and I press this button 1, which is my input, I should get my Sprite. Yes? And that's how it's going to be. If I press button 2, I should get a Coke. Button 3, I should get water. And button 4, I should get Fanta. Now, this machine must be functioning right. Why? Because for every specific X that I put up, so it was 1, Sprite came out. Button 2, Coke came out. Button 3, water came out. And button 4, Fanta came out. Now, that means it's a specifically functioning machine. Now, let's do another one. This time, let's try this. I press button 1, I get Sprite. I press button 2, I get Coke. And I press button 3, I get water. And I press button 1 again, and I somehow ended up getting a Fanta. Now see, look what happened right here. The introduction I told you a while ago, that for every specific input, which is 1, I should have only one specific output, which it should have been Sprite. But look what happened here. I have 1, I got Sprite. I pressed 2, I got Coke. I pressed 3, I got water. And I pressed 1 again because maybe I wanted Sprite. And look what came out. Fanta. So now look at this. I have 2 different Y values for one X input. Therefore, this becomes a not functioning machine, because now it's not reliable. Sometimes it'll give me Sprite, sometimes it'll give me Fanta. Now let's try another example. Let's say I pressed 1, I got Sprite. I pressed 2, I got Coke. I pressed 3, I got water. I pressed 4, I got Fanta. And I pressed 5, I got Sprite. Well, Mr. Crampton, the Y's doubled here. Well, that's okay. You know why? Because look at the X values. They are different. So perhaps, maybe this situation, they realize that, hey, more people want to buy Sprite than this particular vending machine. So guess what we're going to do? We're going to give them more buttons to get to buy Sprite. So even though here the Y's doubled, repeated, as long as the input never repeated, you are okay. That's a function. So now let's proceed to relationship functionality given a graph. The graph, basically the rule is just this. If you drop a vertical line anywhere on this picture, if I drop a vertical line anywhere in this picture, I should only touch the graph that is given to me at one point. So look at this. I'll pick any spot here. Maybe I'll drop it on 1. Look at that. I drop a vertical line here. How many times did my blue line touch the red graph? 1 time. So therefore this is a function. Let's go try another one. Oh, there it is. I picked this spot right here, 2. I drop a vertical line on 2. Look what happens here. I hit 1 and I hit several of them. Not a function. Why? Because my vertical line hit the red graph, or the graph that they gave me, more than 1 time. So more than 1, not a function. Let's try another one. Here. Yeah, Mr. Krams, can I drop it here? Yeah, I only hit 1. Okay, but what if I did it here? I'm hitting 2. Again, not a function because it hit it more than one time. How about this one right here? Pick any spot here. I can drop it here. How many times did it hit it? Once. Therefore, it is a function. So that's how you determine functionality. Okay, there's 2 different functionalities I've given you so far. As long as the x does not repeat, you should have a function. But that's it. As long as x does not repeat, you should have a function. So let's try this one right here. I'll give you ordered pairs this time. So here's the steps that I need you to do. Step 1, scan for doubles. If you scan for doubles, erase the second one you see. After you scan for doubles, look if there are repeating x's. If none, it's a function. If the x's still repeat after you've scanned for doubles and erased one of them, that means it's not a function. Okay? So again, scan for doubles, look for repeating x's after you've scanned for doubles. If you see any repeating x's after that, not a function. If you see a repeating x after scanning. If you don't see a repeating x after scanning, it's a function. Again, notice I never mentioned anything about y. So let's take a look at this. 4968 4974 -35. Okay, I see that there's a repeating pair. So guess what I'm going to do? I will delete the second one. Then I look for the x's. 4, 6, 7, and -3. There are no repeating x's. This is a function. Look at the next one. 3968 310 74 -35. I look at it. I don't see anything repeating, so I can't get rid of anything. Then I look at the x values. 3, 6, 3, 7, -3. Okay, I see 2 repeating x's. That means that this is not a function, because now look what happened here. Based on my illustration, button 3 gave me number 9 and button 3 gave me number 10. Unreliable. Same button giving me 2 different outputs. Not good. Now here's the next one. Again, let's scan for doubles. 3968 310 74. There are no doubles, and I'm going to scan for x's. Oh, there it is again. I see that button 3 was giving me a 9 and it was giving me a 10, so therefore the x repeated. Not a function. Okay, so let's do a flip on it. It's okay to have more than one. It's not okay to have more than have repeating x value.